This is the second lecture from Module 5, Objects and Classes, and we'll start to talk about the relationship between objects. And again, the object-oriented paradigm treats computation as this interaction between objects. So these objects have relationships. And there are three basic relationships. The has-a relationship. One object contains has another object. So inside an object, you build another object. The is-a relationship. This is inheritance. We've talked about this before also. One object is a variation or an extension of another. So we might have a generic class of rectangles and then have a special class squares. Well, a square extends rectangle, but square also is a rectangle. And then association, which is basically everything else. And we're not going to talk about that much because it doesn't actually show up that much in the course. Anytime one object interacts with another object and it's not involved in a has-a or an is-a, we're just going to call it association. Now this has-a relationship is what we're going to focus on in this talk. The is-a relationship will flesh out a lot more next week. Okay, so the has-a relationship. Basically, every program has this. Your class containing main is going to create some other objects. Well, right away you've got a has-a relationship. That class has other objects. And it can be nested. I mean, we've seen this, right? Java.util.scanner, right? In that import statement. Well, Java's an object, and inside of Java there's a smaller object called util. That's the thing that contains all the utility functions for Java. And inside that object there's another object called scanner. You use this form when you have complex objects are made from other complex objects so that you can have this nesting. A car has an engine, but an engine has a fuel system, and a fuel system has a carburetor. So each of those might be separate objects in a highly detailed simulation of an automobile. By the way, we're gonna talk about this referencing in a minute. Java.util.scanner. That's a good way to get hold of pre-built Java objects that are built for you. It's not a good way to do the communication. We'll talk about why in a minute. We have some examples already in the homework and the sample files. So last week when we talked about arrays, we built an array, right? And we had a class called random data that contained the array and had methods that operated on the array, and then had a random data controller. And inside the random data controller, it said random data, my data equals new random data. In other words, the random data controller has a random data object in it. And this is pretty normal. Oddly enough, objects can contain themselves, so you have class foo, and then inside main you say foo object 1 equals new foo, and what do you know? You've created an object of that class. I think this may sound confusing, but it's not a bad way to think about main as being actually external to the file that it's in. Think of main as if it was magically separate from all the classes. And then it makes sense. Oh, okay. If main is separate from all the classes, what you've really got is some unnamed invisible class that happens to contain foo. Okay, communication within these objects. Here I've got an example. I've got 3 classes, and I've put them all in one file, which you should never do, but you know, this is just for presentation purposes. So I've got this class top, I've got this class middle, and inside middle, and I've got this class bottom. And top contains an object of the class middle, so top has a middle class. And we're going to call that object M for middle. And middle has another object in it, right? Middle has bottom, so middle has a bottom. Top has a middle, middle has a bottom, so there's our nesting. And one way we could access things from the top, if the top class needs that bottom to have some kind of a value set, you could do this, object M dot object B dot set X 15. So what's happening? We're setting the X attribute inside that bottom class at 15. Now look at the names. Object M, that's the name of the middle object, object M. The name of the bottom object is object B, so object M.objectB.setX. That is perfectly legal. Don't do it. And I'm going to explain how not to do it and then why not to do it. What you're doing is you're reaching through too many classes. So the top is reaching through the middle down to the bottom. You really only want to talk to the class that you're directly associated with. If the top has a middle, it should only talk to the middle, and then let the middle deal with what's going on in the classes that it has. So here's a different way to do it. I create, inside of middle, I create a method called setBottomX, and then it says object B.setX new x. So basically I only let the middle set that value down at the bottom. And then up at the top I say object M.setBottom. So what I'm doing is from the top I'm calling this method, and then this method will pass that request along down to bottom and actually set the value of the x attribute. Now it seems like it's a little more work because it is a little bit more work. But here's why it's a good idea. Consider up here if I change the name of object B in the middle class. Now I have to change the name up here too. And if I've done that a lot in my software, I might have to change dozens of names, which are completely arbitrary, right? I may have to change dozens of them. I have to remember where I put them all. Maybe class top isn't the only one that did this bad trick, and so now I've got to go back and try to figure out where I referenced it all the time. Now, one way to do that is to get a million error messages, but that's the most annoying way to do it. Also, maybe we're doing set x here, right? What if it was a more complex method? What if it was not just a setter and a getter, but a method that had a name, and then you change the name? You change the name of that method. The old way, you'd have to change it up here too. But in the new way, it's an easier change because it's directly related to the class that contains it, so you know where to go to change that method. If you have these long arbitrary strings of objects reaching across 2, 3, 4, 5 objects, then it's harder to remember where you put all these things. And if you change something at the farthest end method or the lowest method, the lowest class, then you have to go and hunt and figure out where you put all these references. Whereas if you do it this way, it's cleaner. This is not about code operation. This is about code development, and it's about code maintenance. So remember, one of the major things I keep saying, one of the things I hope you take away from this course: write your software for humans. Write your software for humans so they can understand what you're doing. Write your software for humans so they can modify what you've written without getting into a giant ugly mess. And then the last thing to talk about with the has a relationship, you can create an array of objects. So here we're going to have the zombie chases somebody game. I've got my zombie class, and I didn't do anything. I'm not showing all the attributes. I'm not showing the methods. I'm just showing two representative attributes: X location, Y location. Right? Every zombie is going to have an X location, Y location. And then in order to play the game, I need a bunch of zombies. So my zombie controller class, private zombies, but notice the brackets, it's going to be an array of zombies. And then inside main, I actually make the array. Okay, so now I've got 100 zombies. Not quite. What I've got an array that's ready to have 100 zombies in it, but I've not yet created a single member of the zombie class. So what do I have to do? If I have an array of objects, I have to go through and create every one of those objects in the array. So here's my normal here's my normal loop, right? Here, I've got an array of zombies called zombies, and so I start at the 0th zombie, and then I go up to zombie.length, I++, and for every single element inside the array of zombies, I have to create a new zombie. And now I truly have an array of zombies. And then I'll have to go through and do some kind of an initialization on each one of those. Zombies I dot set x location I, zombies I dot set x location 0. So what I'm doing is I'm basically laying all the zombies out on the x-axis. Even this is, is for demonstration purposes. Ideally what you would do is your zombie would have an initialize method, and you would just say for I equals 0, inside your loop here, you would do zombies I equal new zombie, and then zombies I dot initialize zombie. And let the zombie take care of all the details. But I wanted to do an example here that was fairly simple. So remember, when you create an array of objects, what you have is an empty array. And you have to go through and fill in every element of that array with an object. This shouldn't surprise you. When you create an array of integers, it's basically an empty array of integers. I mean, Java sets them all to 0 for you, but those weren't the integer values that you're interested in. So it's effectively, even though you created an array of integers, what you've got is an array that has parking spaces for all the integer values that you're interested in. And it's the same thing here. When you create an array of objects, you've really created a bunch of parking spaces for where you want to put all your objects. But until you do the new keyword, remember, you don't get an object. So many of you in your projects have this kind of thing where you're going to have an array of objects. So I thought we should point that out, that you create the array, then you have to create every element in the array. And then lastly, I'm not going to spend much time on the is-a relationship, which is about inheritance, because next week we're going to talk a lot about that, and we're going to talk about it in the example files here. So look at the example files that go with this module, and we'll talk about them in the live lecture too. But the is-a relationship, that's the inheritance relationship. And it's whenever you have some more specific class that is an extension of a more generic class. So square is a rectangle, turtle is a reptile, sheep is an animal. If you have some high-level class and then another class extends it, we can say that the lower-level class is a version of the higher-level class. And the correct terminology is actually it's superclass and subclass, but we're going to use parent and child because the inheritance relationship makes sense in terms of parent and child. Yes, you can keep extending. So over here I've got public class phi, phi extends phi, fo extends phi, fum extends fo. You're allowed to do that. Oh, but by the way, since phi extends phi, man, I shouldn't have used these names, right? Phi is a phi. It's the is a relationship. Phi is a phi. And fo is a phi. Now, since phi is a phi and fo is a phi, fo is also a phi. And this continues. You normally won't have this much of an extension, normally. I should say in your projects. In a real-world, large, sophisticated piece of software, it's very possible that that can happen. When do you use the is-a relationship? When you have similar objects that differ in their behavior. I can't say that enough. Differ in their behavior, not an attribute value. If you think, oh, I'm going to have two objects and they're differing in their behavior, and the way I get that different behavior is by changing an attribute value, that's not inheritance. When I say difference in behavior, I mean their methods are different. So for example, sheep, sheepdog, they both have the move method. But when I code the move method for the sheep, it's going to be all about running away from the dog. And when I code the move method for the dog, it's going to be all about accepting player inputs and responding to how the player wants to move the dog around. So it's the same name for the method, it's the move method, but it's two different bodies of code inside the method. That's how you know you're going to have inheritance. A lot of the methods will be the same. In the classic ship example, all the ships move, all the ships turn, all the ships speed up, all the ships slow down. All that's great, but their move methods can be different. Submarines can go underwater. Normal boats, ships, that's bad. So their move method can be different. Maybe the way they do some other operations are different. You can have brand new operations for some, like aircraft carriers, airplanes can land on them. Other ships, that's normally not a good idea. So that's how you know you have an ISA relationship, an inheritance relationship, is when the methods are different. Now you may still have some different attributes, but that's the primary thing. The methods are different. And we're going to talk about that more next week.